Welcome back to Designing AI-driven personalized learning environments course. In this lecture, we'll talk about the architecture of personalized adaptive learning environments. So we'll talk about PAL. I think as we mentioned in the last lecture, the name can be ITS, Computer Adaptive System or Computer Intelligent Systems, CAL. So in early 1990s, it's called ITS, Intelligent Turing Systems. Even now, it's called ITS. It's not that we changed, but we prefer the name PAL. In 1990s, this is the one classic picture we got from the Intelligent Turing Systems AI review article journal. It says that ITS or the PAL is intersection of computer science and cognition, that is a psychology where we talked about learning theories, and education and training. The educationists will come up with the pedagogy how to teach it. The psychologists come up with how the people learn, and we use this knowledge using provide the content to the learner using computer. So educators are trying to teach to the learners with help of psychology already. Can we take this to the masses using computer? That is this particular idea of computer assisted instruction or intelligent tutoring systems. Let's keep it very simple. This is if it is for the system level users, or to make it simple, this particular picture is very important. For example, what we do, student is interacting with the student interface. For example, here the student is talking to the computer, the screen. It can be the laptop, mobile, or any devices. All the students' interaction, whatever student does it, student maybe logs into system. After logging in, based on the student's validation, it goes. All the students' interaction can be the way they are typing, the navigation from one page to other, the time they spend on each page, the way they are watching the video can be recorded in the log files of the learner. Here, this also logs something about learner's performance. If I given a particular question, say 10 questions, how the learners is performing on those questions. It can be asking the learners to create a causal map. It can be asking the learner to create, solve a particular Scratch kind of programming where the learners have to create a program and run it. The assessment is not necessarily, MCQ kind of questions. So all those content to provide to the learner comes from the learner content. There's a database which contains all the content needed to teach the learner on particular topic. All the learner's interaction on the topic, including the assessment performs, is stored in the log files. That log file is used to create the learner model, that is a student model. It tries to understand what is each student's performance. The student model contains, this domain model contains set of topics, set of topics to teach, assessment, if you want to provide, you think that if the student is not able to solve a particular problem, I want to explain in more detail. We call that as a remedial content. The remedial content can be also considered that if you understand student have a struggling in particular concept, I want to give that particular concept remedy content, right? So it can also have a content in remedial content. Or if you observe the student's preference type of multimedia is not a text, the student prefers something in the video. So you could have a content in multimedia content of the same topic in a multiple types. That can also come into picture. So the learning database contains everything you want to teach about learner in the learning database. Now the learners interact with the learning database content provided to the screen. All the data is stored in the log file. That log file data comes to student model. It tells about, it kind of stores a data. It's not in this format, but I'm just assume that student 1, student 2, student 3, student 4, student n. There are like n number of students. So the idea is that each student's interaction with the system, each student's performance system, whatever you would like to store, you store it here in this student model. So student model is the student's performance on the content provided and the stored here. So student model can have, if there are 100 students, we'll have 100 students data. But learner model, that is the domain model, the learning content database domain model will have only one set of content, that is to teach the learner. All the possible contents has to come. It is the brain of the system, that is very important, which tries to provide, if the learner is interacting with the system, learner is not able to solve the particular sum after taking 4 ins. What should I do next? Maybe we could say that I would like to teach the basic concepts. I want to learner to redo the watching the video again. I would ask the learner to go back to the previous concept in the particular topics. So that decision can be taken by the adaptive engine. The adaptive engine is the brain of this intelligent learning environments. So mostly this adaptive learning engine is rule based system only. Which means if else logic. If the learner fails the particular topic, the score is less than 0.8, redo the topic. If the learner is not able to redo in the second attempt, give them more video content. If the student or the learner is not able to complete a topic, even 20%, maybe give the advanced topic, like previous topic or basic topic or something like that. Set of if-else logic rules has been used to provide the rule-based content. This is how the ITS works in general now. Now the idea is that we convert this into the ITS4 architecture. What we want to teach is the domain model. The learning content database is called the domain model. Okay. Who is the learner? This is the learner. Learner's interaction is stored in the student model. The who is the learner is stored as the student model is the learner model. Learner or student model. How to teach that the brain of the system is the adaptive logic, the logic, adaptive engine or rules we talk. It's a pedagogy. It's a pedagogy model. So these three are the basic, very key components of personalized adaptive learning environment. That is what we want to teach, all the content stored in domain model. And about the learner, learner's data, learner's performance is stored in the learner model. How to teach is the adaptive logic, that is the pedagogy model. And where to teach, it can be VR, web, classroom, lot of interfaces. That is a website comes into the user interface. That is kind of used to provide support to adaptive logic. So these are the 4 major components. So we had like in the particular same same paper they talked about another architect of the ITS. They use the word model and module interchangeably. So we are thinking we want to classify what is module and module clearly. It is called user interface module, expert knowledge module, student model module. This is the word student model module, tutoring module. So in a computer science, each component is considered as a separate module. They try to integrate multiple modules together to create a system. But it's kind of confusing. So what we use in our system is instead of domain module, we use just a domain model. Student model module becomes student model. But pedagogy, we'll use the module. PED module will use it, or PED model also fine. We use the user interface only. I hope it is clear that there are 4 components, major components in the personalized adaptive learning environment. We will name it as a domain model, student model, PED model, user interface. In the next 2 videos, we will talk about these 4 models in detail in sense introduction level. In next 3 weeks, we will talk about these modules in detail.